So now we're gonna start the new web course seminar. Uh, Everything's about crowd analysis. So from my catalog, I can see there are 7 courses. Uh, they have same called crowd analysis solution. And from now, I'll just start one by one and make corresponding recording. So it's gonna be a long video. And get ready, motherfuckers. Now I just deployed and downloaded the crime analysis, and I can start using ArcGIS Pro. So the first part of the crime analysis. Um, so we can use select layer by date and time to locate from the attribute. Like for example, we we want to focus often the 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 offense time. Uh, so you can just do this select layer date and time to just uh, choose whichever you want. Just pretty straightforward. And now I'm gonna focus on this. This one is from the total manual of the crime analysis. It has so many different functionalities. So I'm gonna go through all these analysis tools and yeah. Yeah, here's the 80/20 analysis. So the basic idea of this one is like to analyze three segments that contribute most significantly due to the volume of costs. So like 80% outcome from 20% of costs. So like from 20% streets. And so there are four different, attribute table from the outcome of the analysis. And it's being sorted by descent order. And number 10, that means like top 1 to 10, like the incident count from 28, that's the largest, to the smallest. And the incident percentage, like the percentage of total incidents that occurred on the specific segment. And accumulatives, like, for these two parts, like, uh, so for the top 10 uh, streets, and they have like 20, they have accumulated 21% of the incidents, but only has 0.17, like, you know, location percentage. So like only this tiny of the location. So this tiny part of a road has 20% of the incident report. That's what that means. So you see, the record number 10 and before you see okay over here. The top 10 street segment account for 21 and 53% of cost for service, as shown in the accumulated in the purchasing column. However, its 10 segments only made up 0.70% of all street segments. So that's what that means. And there's another concept like incident per mile, incident per kilometer. So I just sorted essentially by this category, and you can see the top number isn't the one with the high incident count. That means, uh, all different street segments. I mean, they're not equal size, right? So, uh, the one with highest incident percentage or incident count, that means you have highest, incident density or per mile. And by having different, category like this, we can compare relative concentration of incidents across the segments of different lengths. And now I'm gonna record how to use this tool while I already opened, and input point features, which is the it's called for service. So I'm gonna check the attribute table. That's input data. It just provide, the location and numerical information like where that is. Just very generic. And the streets, maybe let me check that. Yeah. You can download this from any city government street, data later, and it's not a big deal. Uh, Aggregation master gonna be cluster feature because you're gonna oh shit. Aggregation master. Okay, so here we go. So like you don't have a cluster because you want input point features to be aggregated into a line feature. So you have to select the second option, which is close the feature. And comparison layer, comparison feature, we select streets. And that's the object which is gonna be aggregated upon. This section only be active because you select as the aggregation master, which is closed feature. Also keep in mind there's a US address to your ranges naming masters. So I was so confused. I have no idea why they have so many numbers, and they have these weird names. But it's only and like after checking the ChatGPT, I learned that that's a naming master, right? So left from address, starting lowest address number on the left side of the segment. That means 200. Left two address. This is ending highest address number also on the left side, not on the other side. So that means 200 201. Same as the right side. So by having this block number, you can, you know, probably find out like if you have a number of household, you can probably locate where that is. And that's why for the outcome, you probably want to know the right from the address, which is, smallest number on the right side and left to the address. Two, that means the small number from the left from the right to the largest number on the left. That do make sense. So in the end, I want to show you one last part. You can do some labeling, kind of smart labeling, and because you can rely on expression to have extra labeling on the top 10 on the top 10 streets that has the highest incident count, and that's expression from two. That means the block number of the streets. Okay, I'm gonna read this. So you can have a custom label expression using Arcade to show the street name, of course, over here, street name. Yeah, street name and the address address range of each segment, of course. The number of calls on that segment, so that means incident count over here, I count, and the percentage of all calls that three segments counts for, yeah, just over here. Yeah, that's really big. It's 3%. So, and yeah, with percentage, don't forget about that. And so, for example, this rate. So here's the all tutorial of the 80/20 uh, analysis. Thanks for watching. So this part, if you choose cluster aggregation master, you have this map instead of this. But I personally prefer the closer feature. The second one is called collocation analysis. And so there are four different categories of the result. I mean, so first of all, the objective is to examine whether location of the something is collocated with another one. So that means if burglars tend to happen more near the pawn shops. And they have four different categories. You can read through it. And so here's the results, right? And you can see big category into different colors. And the steps of geoprocessing, first of all, input data type. Why I'm choosing datasets without categories is because that's two separate datasets representing two categories. One is pawnshop, another one is periphery. You're not using any single dataset or two datasets. Yeah, because they have different categories. So input feature, input neighboring, neighborhood type, like you have k-nearest neighbor, distance band. In simple words, like distance band, you can choose like what's the distance of from that point. Just draw a circle. And k means like you decide how many neighbors. The closest k feature, like if you decide, okay, we have 90 neighbors gonna be across whole map. So you decide how many neighbors that will be influencing the you know the total outcome. So I would say if you only want to focus on the distance by the best, and don't put any weighting scheme, and you can click wrong. Oh yeah, I got same result anyway. And by the way, how to read this the outcome chart? The p-value, that means if that's significantly important. And the x value, that is LCQ, if that bigger than 1, that means it's collocated. Smaller than 1, that means isolated. You can see from the chart, if I draw a line over here, 0, 0, so like most of their outcome, most of, I mean, actually every single one of the pawn shops locating on the first part of the chart. So that means you have a high collocation with high high p-value. So it's like a lot of the collocated, but notice like the highest collocation LCQ has very low p-value, and just keep in mind. So this part of the project. Uh, it's called points to track segments, and what this tool basically is gonna do is as you can see, that's something like, okay, so that's the location of the phone call of the suspect, and once you make a phone call, there's starter time, and basically this geoprocessing tool can just draw a line based on where the suspect start to make a phone call, and it's basically gonna look like this. So so you can track the location of the suspect by their their phone call. And what is, I mean, this one's not really important. And for the input feature, you must select the size, which, whatever it costs, you must have to find something with the time. You can just, because the whole algorithm based on, just build some kind of alignment of the temporal data, and so the data field, whatever you call that, but just the field must same as the time, and yeah, that's very simple. Okay, so you can also make a 3D visualization. Just keep in mind the time represents the z value. You can see from point 4 to 5. It took them 5.5 hours. That's why the Z beta increased a lot. Other than that, there's nothing more important in this analysis. So this part of the tutorial is called cell-side records to feature class. And this one. And the basic logic of building this tool is to extract the information from the site's phone, just like standalone table. You can see it has XY data over here. I just put XY data to point. It looks like this. As you can see, there are 27 records, but some of the uh, rows you have they're representing the same point. Why is it there's repetitive XY data? Because it also provides different direction and radius data. So that means, I mean, basically the major function of the tool is just to make some map like this. So from this information is called, that's why it's called static records to feature class. So while you have, the most important takeaway is to having this kind of a feature class, and from the standalone table, and you can just visualize and makes the table into some graph, because this graph represents the area which is covered by different site provider, and so when someone's making a phone call at certain area, random area, then the whole site providers can detect, okay, where that belongs. So basically, that's what's called site-side records to feature class means. You can just help us do further call detail records, and we can connect to the call record the physical location to understand where the investigate target was and when they were there. So here's the second part. The implementation of uh, the the outcome from the first part. So like first of all, we made the font size and sectors, and now if there's any reports, for example, we have CDR phone. That's the record phone call from suspect. And based on this information, I already opened attribute table. You can see there's no geographic information. I mean, I would say that's one of the advantage of having this method. So like you can locate the suspect area based on this two thing. No, this two thing, the site and sector. So you can see, for example, this is 40 and 3. So okay, so there's no map, but like, and notice from the part one, we made such a feature class, and if I click this part, so you can see the site ID is matched the suspect phone call area. Thus, we can the outcome's gonna be the gray zone area like this, and that's how we detect the proximate area of the suspect. Find space-time matches. From the first part of our analysis, we made it, proximate area for the suspect. Like this guy gonna be in this area in a time sequential way. And unfortunately, I mean, this guy's making the call to someone else, and luckily the guy also is being detect our size and sector, and here's his location. And this part of the analysis is gonna be find space-time matches, which is the usually evaluate the phone call details and item patterns when two phones were in the same area at the same time. So like space-time matches. But not all space-time all matches. For example, if we open the outcome for the phone one and only you can see color difference. The dark blue means they are, you know, they are within 1,000 feet and within certain minutes call with phone one. So like there's a huge overlap. And the shallow blue is just like the locations are similar, but they're calling in different time. So that's a functionality of flying space and time matches. Yeah. So an article generally call links too, and basically just link the two callers. And you can generate some summary layer. So the tool is commonly used by crime analysis and CDR analysis. CDR basically is called detail record. CDR is a log generated by the phone number operator that records details on each call and includes all this information. So you might wonder why these two feature layers can generate such image like that, how they can just build a link because the CDR has sufficient information and numerous uh, data fields, and which I believe it has a geographic location to help the algorithm to build a certain link. And yeah, also they have uh, XY data, so nothing really interesting. This one is January sector lines, and so that's input data, input layer, and you have this. That's called sector lines. And why we're not using the cell size record feature class? Because in many cases, the true extent of cellular propagation signal is not definitive and can be impacted by environmental or weather factors. So that means the gray zone is just like ideal size. It's gonna be much smaller if there's like a mountain in front of this signal. And for conservative inspection, it is recommended to use generate sector lines so you can present maps without making value judgment about true cellular propagation strength for each cell sector. And that's everything. So this one is called pairwise dissolve. And this tool was used to count the number of phone calls, uh, in one sector. So there are many phone calls. You can see the dissolve fields based on unique ID. So each ID represents one phone call. And look at this. So it's just like the aggregated feature based on specific attribute using a parallel processing approach. So the difference between pairwise dissolve and the dissolve is it processes overlapping or adjacent features in smaller, more efficient steps. And the dissolve only processes a whole data set at once. Pairwise is dissolving the overlapping adjacent features in smaller groups, pair by pair, then process all of it together. And the outcome is because the input is sector, so you can dissolve the sectors and put different color based on unique ID in one sector. So it's called pairwise dissolve tool. This one's density-based clustering, and this tool does not test for statistical significance. That means this one's statistical, and you can validate the results for another non-statistical test called spot detection tool, such as kernel density. You can do some basic validation. And there are three different methods to do the clustering. You don't have to know detail, but just you can look, five clusters, four clusters, they just separate into different areas and just colored. This one is kind of very important. So the input data layers all kind of params and their location. And you have to run different tools. First, create a space-time cube. You have something like this. A bunch of hexagon tubes. And here's a step to create the hexagon cube tool. First of all, crayons and the output space-time cube. And the time field must be reported date. Time step interval 1 month. Time step alignment start time because you want visualize align the first time event and aggregate forwards in time. And then you create emerging hotspot analysis because this one involves temporal, so like new hotspot consecutive intensifying hotspot. You can consider this as different, the speed and intensifying maybe like this, like just increase very rapidly. So you might need to increase you have to identify tactics and strategies to unique temporal trend observed. Consecutive and new hotspot are temporary, recent, and shorter in duration. You have to focus on patrol may be appropriate, while long-term persist hotspots, this is long-term persist hotspots. You have to involve environmental modifications, policy changes, and collaborate interventions. So we're talking about some data cleaning, and we have to use convert time field, add data attributes, join attribute from Polygon tools to enhance the attribute category of data management section. We have a REST layer, so we have to convert to a new date field using convert time field. So here's the input table. And you can see that's the old format of the date. And put that inside as input field and input format. So you want to change the format. So already changed. And output field type is date. So that's first part. Second step is to add date attribute. Input table, date field. I just created a new format and put everything as default. Maybe you don't want this long name, but it's just different, they're going to add different fields, just like this. Some kind of we can enrich the data in this way. Last one is called join the attributes from Polygon. And you can see these are different areas of the place, place zone, and it has different name, different areas. So what you have to do is just join the name of this place area into the rest attribute data, and you can see we have a new name. So for each arrest data, we have correspond uh, place zone over here, and basically 3 steps. We made some data cleaning and standardization task before performing an analysis. This one is called update feature with incident records. I would say it's just like another way of updating the attribute table. The new crime. So we already have 799 records in the old crime, the attribute table showing the map, but we discover a new 15 crimes right here, but the two attribute tables have might have different schema, and what you have to do is just run a tool. That's all basic stuff, and of course XYFU, they both have it. But when you're selecting this, so of course you have to don't must match, you have to use this to reconcile age. And the problem is when I first load this, there's two fields, there's no match. I mean, there's two fields that is from the new crimes. So no, sorry, it's to the new crimes because you see municipality, it was complaining there's no source, and you have to find which field in this new crimes can match the one in the old crime folder, which is municipality and the full address. By inspecting the attribute table field, we realize city is municipality, full address is address. Based on that information, we can select corresponding fields in the source, no, in the new crime folder, and you just click that. Now we update everything, then click run. Now, as you can see, we have 814 rows. That means we successfully updated the new attribute table. This one contains select layer by date, time, kernel density -2. And first of all, we want to know what is the night time selection, which is 7 a.m. to 7 p.m. 7 p.m. to 7 a.m. So from all input data, we use select by time, and we have two separate selections. And now we run a kernel density, and we can generate corresponding daytime and nighttime density over here. Input cell size and search radius can be 1,000 square foot and 100. And finally, we use the -2 to generate a nighttime change in call density. This tool called optimize hotspot analysis tool, and from input layer, counting with hexagon grid, and the boundings like place area, and you have this. I mean, we made hotspot analysis before, but this one is first of all, This is demonstrating the significance of a long-term crime problem. It's not suitable for short-term tactical analysis. Second of all, it emphasized, the high confidence area, like, over 90%. So that's why it's called, optimized. There's a, I don't think it's very useful, but it's called generate or ranging destination links right here. And so if you're a total idiot and you'll be tracked, that's your account number right here. And they also have bank transaction account ID. So you can easily make a link right here. And that's the whole purpose of this tool, original field and destination field. The only difference might be, you have extra summarized field, the value, sum, and mean for each transaction. Yeah, transaction value. And you can also, change the symbology as well, because this tool can generate this kind of arrow, and so as I repeat, this tool can help visualize spatial relationship between two layers sharing a common attribute. In this example, we're dealing with the one-to-many. So that's one-to-many attribute relationship, which many gang member can be related to one single gang, and that's gang territory. Okay, here's the new sequence. I'm gonna read from here. Mm, so we're gonna use the near repeat victimization patterns to build prediction zones of potential future crimes using spatial and temporal analysis of burglary incidents. And first of all, we need to use the export near repeat calculator table tool to convert. So first of all, we have a CSV file of the burglary, and which is compatible with this near repeat calculator, this one. So the first step of this tool, the task, is to first of all that's the report attribute table, and you get export to the repeat calculator, where like you have to adjust this table to the format as can be recognized and processed by the near repeat calculator, and then you run a process. So based on that table outcome, and you can build the prediction zones. See, take the results from calculator, apply significant spatial and temporal parameters for near repeat patterns. Why there's a spatial temporal influence? Because the range of spatial decays decrease on like the longer time the burglary tree happens nearby, the higher decay, and the further the higher decay. So that's basic concept. So here's some more empirical explanation. Repeat and near repeat victimization is an empirical phenomenon where when a crime has occurred at a given location, that location and another location nearby are at elevated risk for future victimization. The risk decays further if you get in time and space for an originating incident. So we can have a approximate measure for detecting serial offending patterns. Here's another part of analysis called repeat and near repeat classification. And basically, uh, with all of the Berkeley input, and it can be classified into different category, and the algorithm will find out the originator, repeat, and near repeat. So I'll give an example. For example, right here, because we have to considering spatial and temporal information. Of course, spatially, these two are closer to this ordinator. And I believe ordinator has the earliest open state. That's why in a local, cluster area, this one is like to be an ordinator. And why this one is grayed out? Because you can see the open state is May 7th. And you see the May 26th, and that's the May 2022. So there's kind of a sequence. So that's why they build a link. Okay. For each repeat and near repeat pattern from the tool classify each incidence as to whether it's first event in a pattern, repeat event, near repeat event. And you can visualize in a 3D map. The z value represents the time. Of course, the 1 almost on the same height has relative closer temporal information. And here's the summarized incident count. So the darker, the more incident in the area. And last two is summarize percentage change tool. And of course, first select layer by date and time. So we can separate Q1, Q2, and put that as input feature. Uh, yes, one's Q2, one's Q1, and input features. So, and you have this kind of percentage change for each section. And here's all of the map of the crime analysis. So that's a really long sequence. You have to spend a lot of time to repeat, but sometimes I would say these are all customized tool, and it is not really practical. So it's only can be used in a certain circumstance where the attribute table is pretty strict defined and regulated. So then you can just implement any tools directly. But sometimes general callings, general sector lines. I mean, you can just use a code. You can just make the code by yourself. Like you don't have to. I mean, this is a customized tool. You just use a Python window to build your own tool, and that's it.